Here we are in West Virginia again, and it is time for Joke of the Day because it is undoubtedly the best part of the day. Okay, so if towels could tell jokes, I think they would have a dry sense of humor. Okay, well now let's take a look at something that's not dry at all, something that's exciting, and that would be domain of functions. So we've talked about domain before, and remember that domain is going to be the input. Domain, when I'm looking at a function machine, domain is what I'm going to put into the machine. And so if domain is what I put into my machine and what I put into a function, typically where do you put your values or your numbers into your function? Absolutely, you typically put them into those x variables. So your domain is going to be all the x values of your function, typically anyways. A good definition of what a domain is the largest set of real numbers. Now that's important to understand. Largest set of real numbers for which the range, and remember range is your output. So if it's the output, it is typically your y values, or if we're talking functions, then it's going to be your f of x, because f of x and y mean the same thing. So my domain then is the largest set of real numbers for which that range is also a real number. Very important to understand, I want my range to be a real number. My output to be a real number. So therefore, that means that I need to stay away from imaginary numbers. Now, what creates imaginary numbers? Because we've looked at that before. What causes imaginaries? Absolutely, a negative underneath the square root. So that means that I don't want that to happen. I do not want a negative number underneath that square root. Stay away from that. Ensure that whatever I put into that function underneath that square root is only going to cause positive numbers or a zero. A zero is perfectly fine under there because the square root of 0 is 0. No big deal. I just don't want to take the square root of a negative number. The other thing that I need to be very careful about is whenever I have fractions, remember in that denominator of your fraction, what do you not want to be there? Absolutely, you do not want a 0 in the denominator of your fraction. Because if you have a 0 in the denominator, then remember that means your fraction is undefined. If it's undefined, that means it doesn't even exist anymore. And I need it to exist because I need it to be a real number. So therefore, I've got to ensure that I do not have a 0 in the denominator of my fraction. So with these two criteria in mind, let's take a look at a couple of examples of dealing with a domain. So in my first example here, I have my g of x function. My g of x function says I have this fraction with a denominator of x squared plus 4, subtract this fraction with a denominator of x squared minus 4. And I want to look at the domain and I want to say, okay, what is allowed to go in for these x's here and that will not cause any problems? Now in this case, I don't have any square roots, so I'm not worried about creating negatives underneath the square root, but I certainly have fractions. So I want to ensure that that denominator does not end up as a 0. That x squared plus 4 had better not be a 0. In addition, this denominator as well had better not be a 0. Now, take a look at this one over here. In order to ensure that that's not going to be a 0, I need to look at it and say, okay, well what if it was a 0? Let's pretend it is a 0. And whatever that answer would end up as, I don't want it to be that. So in order to solve this quadratic, remember we've got 4 methods. We can either factor it, we can slide the 4 over and take the square root. We can complete the square, which is probably not going to do. We can do the quadratic formula, but I'm telling you, either factoring or simply adding that 4 to the other side and then taking the square root will be the easiest way to go. So what I'm going to do now is just take that square root, and that will give me x equal to, now remember the square root was not already on the page, I put it on the page. When you put it on the page, what does that indicate? Absolutely, plus or minus. And I want a plus or minus 2 because the square root of 4 is a 2. But remember, I don't want this to be a 0, so I don't want this to happen, which means I don't want my x to be a positive or a negative 2. Now, look at this situation. So I'm saying, okay, I don't want it to be 0, but what if it was? How would I solve this? Now in this case, what's going to happen is, if I subtract that 4 to get it to the other side, I'm going to get an x squared equal to negative 4, When I take the square root, I will get x equal to plus or minus, because it wasn't already on the page. Square root of 4 is 2, but when there's a negative underneath the radical, that indicates an I. But remember, I don't want those imaginary numbers, so I really don't want this to happen. Also recall, back over here, I didn't have to solve it this way. I could have factored it. If I would have chosen to factor it, I would have got an x plus 2 and an x minus 2, giving me x plus 2 equal to 0, or x minus 2 equal to 0. Now if x plus 2 is 0, x is a negative 2. If x minus 2 is 0, x is a 2. Giving me the same result that I had here of plus or minus 2. Remembering, I really don't want this to happen. So either way I go about this, I'm simply saying I don't want that x to be a positive or a negative 2. Going with this idea of factoring, I could have tried to factor this, but we've looked at this before with a sum of squares. This is a difference of squares. Difference of squares factors beautifully as an x plus 2, x minus 2. But a sum of squares can't factor. I would try to make it an x plus 2, x plus 2, but that won't work because I'll get a positive 2x, a positive 2x, giving me a 4x in the middle. That doesn't happen. In order to cancel out the outsides and insides, it would have to look like this, but that gets me to an x squared minus 4. This will not factor. So therefore, I'm just not even going to consider this. This is my consideration. In terms of my domain and what's okay to go in here and in here, everything works except these two numbers right here. Literally every single number that is a real number, not an imaginary, but every real number will work except for these two. So therefore, my domain then is going to be everything from a negative infinity all the way up to a positive infinity. However, I got to skip over some stuff because this negative 2 cannot be included. So therefore, everything from a negative infinity all the way up to a negative 2 is going to be okay. Consider the number line. Here's my number line. Here's 0. Here's positive 2. Here's negative 2. This indicates everything back here is going to be perfectly fine. Everything up here is going to be perfectly fine. Everything in between is okay, just not this negative 2 right here and not this positive 2 right here. Everything in between is perfectly fine. So everything from a negative infinity up to that negative 2 is okay. That negative 2 is not included. We've looked at that before. That means parentheses. Bracket means it's included. But I'm going to skip over that negative 2 with that open circle and pick it back up on the other side. So to pick it up on the other side is going to say, well, let's grab it like this. And let's go all the way up to the positive 2. But again, it's not included. It gets a parentheses. And then I'm going to skip over the 2 and pick it up on the other side and go on. So pick it up on that other side of the 2 and go on to infinity. Now these three intervals, though, they are one big picture. So to say that this is not really three separate intervals, it's part of one big picture right here, I'm going to put a U between each one of them. And therefore I'm going to unionize them. And that is my domain. This simply tells me that what's okay to go in here and here is everything from a negative infinity to a negative 2, but not including that negative 2. And then pick up on the other side of the negative 2 and go all the way up to a 2, not include either one of these, skip over the 2, pick up on just the other side of that 2, and go all the way to infinity. Those are the numbers that are okay to be included in that domain. Now, let's take a look at this situation. Once again, cannot have a 0 in the denominator of a fraction. Now, I don't have any fractions in here. I'm not worried about that. But I also do not want a negative underneath that radical. So that x plus 2 that's underneath there, it had better not be less than a 0. I don't want that to happen. I don't want it to be less than a 0. The easier way to look at this, though, is to say, well, then that means that that x plus 2 could be bigger than 0. That's okay. Is it okay for it to be a 0? In other words, could I put a 0 underneath that radical? Sure, because the square root of 0 is 0. So it's okay for it to be 0. It's okay for it to be bigger than 0. Here is my criteria. I need to solve that inequality. So I'm going to subtract 2 from both sides, giving me x greater than or equal to negative 2. Remember, the only time you flip that symbol is when you multiply or divide by a negative. I didn't even multiply or divide at all. So here is my criteria. All the numbers that I'm going to put in here, they need to be bigger than a -2, or it can be a -2. So when I look at my number line, and here's 0, here's -2, anything bigger than that -2 is up here. All of that's going to be okay, going on forever, and the -2 itself is okay. So remember, that's not an open circle, that's a closed circle, or in our effect, a bracket. So what that means is, in terms of my domain, what is okay to put in, and I'm going to write an interval for it, that means everything going from the -2 up to positive infinity, which always gets a parentheses. The -2 is included, so it gets a bracket. There is my domain. Everything from a -2 to a positive infinity. So hopefully that helps you to understand how to write the domain of a function. What you need to do is exclude anything that would cause a 0 in the denominator of a fraction, exclude anything that would cause a negative underneath a radical, but causing a 0 is okay. Exclude those things. The easiest way to go about it, quite frankly, is to draw a number line and say, okay, what would the number line look like? And then just simply write your interval from that number line, as I did in both of these cases. So I hope that helps. Have a great day.